This is an update on how to do the simulation for the beam test assignment. After working with students and doing some more simulation on my own, I think I have a better strategy now for how to really use simulation to work on your design. The first thing to do is, if you already have a simulation, we're going to create a new one now using a slightly different technique to get some more useful colors and some more useful safety factors that can inform your design. So start by going to Finish Results if you're already looking at some results, and create a new study if you have not started, if you have an existing one already. Otherwise, you can just move from Design to Simulation and then click on Static Stress Study. So we're going to do another Static Stress, Create Study. Alright, the problem before was that using these outer pins, where we're going to put the bolts in real life, was producing some very low, or very high deformation and high problems, high stress points around those points as we were testing. So we're going to fake it a little bit and use these outside surfaces as our constraint. This seems to work a lot better. So we're going to go to Constraints, Structural Constraints, and instead of selecting this hole, we're going to select this face on the outside of your beam to lock that in. And we're going to also lock in the other side. Those are all your structural constraints. Now, I haven't seen a problem with using this face right here for your load, but there's an option to make a little bump on the top of your beam and then use that face too if you think that you're seeing some problems with this using this face. So to do this, we go to Load, Structural Load, and select Zoom in a lot and select the inside of this surface, not this line here, but the inside of the whole barrel there. You should see an arrow going down or up. Either one of those would be fine. And then we're going to change our force. I'm actually finding much higher forces are giving me better information. So I'm recommending 10,000 newtons as if this beam was in steel, which is what it thinks it is. 1, 0, 0, 0, 0 to make 10,000 newtons there, and click OK. One other suggestion is when you're running your studies, some students have had some great luck with solving their study locally as opposed to on the cloud. You might have to install a little add-in, and if that doesn't work, on the cloud works as well. It just might be a little bit slower. You can click Solve. This I've found is pretty quick. Let's see if it still is. And then once this is complete, you can see your actual safety factor here is still pretty high. We aren't actually that interested in building a very safe beam. We're kind of interested in making one that just barely holds the weight we're looking for. So I have a pretty high safety factor here, so I'm going to add a little bit more weight to this. So I'm going to Finish Results. Study, New Study. You can change your old one too, but I'm just going to model it doing this way because I think it's a little bit simpler. I mean, might be simpler. It might not be as well. You can also change your load. Now that last number I got was 1.4, and so I am going to multiply what I did before times 1.4. That's pretty easy with starting with 10,000 newtons. I can go 14,000 newtons now, and that should produce a safety factor near 1. We'll see. Solve and solve. Oh, I think I did that one on the cloud. Did I? I might have done that one on the cloud. It might take. Oh no, it's done. Okay. There we go. That safety factor is 1.02, which is definitely in the range we're looking for, between 0.9 and 1.1. And we've got a lot of colors to look at to figure out where the weakest point in our beam is. I would say that the yellow in here is the sort of worst spot. I'm also seeing that my worst spot is right at these corners right here, where I could maybe round that corner to make that a little bit stronger. This blue part here and these green parts here are seemingly pretty strong, so maybe I don't need to worry about those. And I think I would actually choose those corners as the place where I add material, and maybe these whole upper parts as somewhere where I would remove a little bit more material. You would take a screenshot of this and then maybe zoom in and do a screenshot of your actual weakest point, and make sure to show your safety factor in that screenshot.